to the last day of the session, being the fifth day. Professor Arial, who is from Brazil, will be delivering the session today. The current time in Brazil is 7:30 a.m. So, but I'm sure Arial is there on the line, and
yes, I'm here.
Yeah, Arial, good morning.
Good morning. Good evening, in fact.
For us, it is good evening. For you, it's good morning. So the participants are still joining. So they may we'll wait for one more minute. Meanwhile, I'll just introduce you once again to all the participants. Ariel Soares Teles is from Brazil. He's my very good friend. We are working, and we have worked on so many assignments in the, and he is Ph.D. from the University of Maranhão, Brazil, and he's also a postdoctorate from the Brazil itself. Currently, he is an associate professor in Federal Institute of Maranhão in Brazil, and his research areas are mainly ubiquitous computing, mobile computing, Internet of Things, artificial intelligence to solve healthcare informatics issues, and so on. And I welcome you, Ariel, not only in this session, but on behalf of India, I welcome you, and we look forward to have a nice informative session with you. And already, as all the participants are aware, and the schedule for today's session is mainly focused on machine learning, TensorFlow, and practical aspects of IoT, and Ariel will be using Google Colab. So all the participants, I request your sincere participation. You may interact with the speaker, and wish you a good session. So Ariel, now over to you.
Thank you. Let me turn on the camera. Are you seeing me?
Yeah. Yes, I can see you. And I believe all can see you. Yes.
Yes. Good evening. Thank you very much for the opportunity to be here. And I'd like to say that this is a great opportunity to share some knowledge. And I have here 2 monitors. And I think I can present something interesting to you. And let's get started. I'm gonna share my Are you see my screen?
Yeah, it's getting uploaded, Ariel.
Okay. I'm gonna turn off the camera.
Yes, we can see now.
Okay. The title of this presentation is Introduction to Machine Learning with TensorFlow. My name is Arial Soares Teles, as Nishu told you. I'm a professor at Federal Institute of Maranhão, and let me first introduce myself. As you can see my accent, I have a Brazilian accent, a Brazilian English. So I was born in Parnaíba, Piauí, Brazil. I received my bachelor's degree in computer science from the State University of Piauí, and master's and Ph.D. degrees in electrical engineer from the Federal University of Maranhão. I'm focused on ubiquitous mobile computing, Internet of Things, and artificial intelligence to solve problems in healthcare, mental health, and other things. So I have works in these areas. Maybe you can see my works focused on these areas. First of all, let me say something. We are talking today about hard subjects. It's not so easy to talk about this. So I think we can have a methodology in which if you have doubts, if you have questions, you can say, and I can try to solve and answer your questions. So I think we have a little bit hard subjects to study today. So part one, machine learning concepts. I think you know the most of them. Learning from IoT. Main Python libraries used for data analytics and machine learning. TensorFlow concepts. And part two, we are going to we will practice some code, we will program a specific code with TensorFlow. But first, what's machine learning? Machine learning, we can say that it is a class of algorithms used to make computers smarter. So machine learning is an amount of algorithms that we can teach the computer to be smarter than it is. So these algorithms can generate models. We call this name model is used here to say when we have a program already trained by an algorithm, able to understand and solve a specific problem. There are many types of problems, but we today will focus on classification and regression problems. But there are other types, for example, clustering, grouping, anomaly detection, and the others. Normally, I put some YouTube links to, if you want to know more about this subject. Normally, I use YouTube links. But classification. Let's imagine that we have a program, and this program, this computer program, needs to classify these images. Do you know Simpsons? Everybody knows Simpsons? Anyone? Anyone?
Yes, Ariel, we can see. Yes.
Okay. So, can anyone imagine how can we classify these images? For example, we can classify by colors. We can classify by objects, or like this.
By gender.
We can classify by gender. So a classification task is when we need to select images or data, any type of data. And for example, to classify that data between or among sets. For example, here I classified this image by home, by place. For example, here are the personages that live at home, or here are the personages that live in, that not live, but we can see them in school. And other type of classification would be by gender. For example, I have here images, woman and man. So what I want to say is we can classify image data using different types of context, different types of characteristics, and different types of views. This is a classification. Here we have data. This data represents cycles and plus. And we pass many examples to the computer, and the computer understands the characteristics and or features of the examples. For example, here, the computer can understand the format, the color, or other types of characteristics, and they can understand what that example is. And after train it, a model can understand other or unknown examples. For example, here, if I give this example to the computer, it can understand, it will be able to understand what this example is. So this is a classification. I'm here dividing and put examples here to show cycles, and here plus to classify plus. Regression. Regression is another type of task, and regression here is when I have two variables or more, but here I have two. I have here price and size of the house in general, and here I can understand if I give to the computer, for example, a price of a house, I can get back its size, for example. So in this case, I can predict, or I can see the price. If I give more examples to the computer, it can understand it can predict the price or the size of house. If I want to understand, to predict the size of the house, I have to put this variable as dependent variable and this variable price as independent variable. So I have the price and I would like to know the size. Or the opposite, I have the size and I have to know the price. So here I have a regression task because I need to know numbers. I'm not sure if you understand, but if I have a classification, I need to classify examples. If I have a regression, I need to predict. I predict examples. So here I have a regression. In this case, I have cycles, and these cycles have two or more characteristics, features, and as we can see here, they are spread. They have different characteristics, but if I put a new example here, it will be identified, and it will be not exactly identified, but it will be, I can predict this example. If this example is in the future, I can predict it. So regression can see the future for a temporal series, and it can predict, it can identify the dependent variable from the independent variables. This is another example of regression, but in this case we have here a function, a different function to represent the regression. We have many examples here in blue, and we have in red the function, but in this case we have a good function, or not so good, as we will see. This function it's much adapted to the examples, train examples. And in this case, we can see many examples, but the function is much adapted. It's very adapted to the examples. And maybe if we put more examples, it will be wrong in detecting these new examples. So, but I have showed to you two types of tasks that we normally use machine learning. But when should we use machine learning? When and why? When I cannot write a deterministic algorithm to solve the problem. So if I have a problem, either I cannot write or think in a deterministic algorithm. In this case, probably I can solve this problem using machine learning. In this case, we have to look for knowledge from examples. So if I have many examples, I can give those examples to the computer. The computer understand and see and have that knowledge from the examples. And it will be able to understand new examples that are presented to it. So we have here when to use machine learning. These are the steps used to process, it's like a development process in data mining. First of all, I need data. So I need data. Data is the most important thing in machine learning. So I have to get data, and with this data, I can prepare this data. This data is normally normalized, transformed. It has to be transformation, validation, filterization. It's like I have to prepare the data to be processed by algorithms, machine learning algorithms. And I had to do this, data preparation. Normalization is put between 0 and 1 or minus 1 and 1. Validation, I have to see if there are new values, and that's it. And after preparing the data, I have to build and train models. But what exactly models? What exactly model is? Model is a function. At the ending, it is a function that was prepared by machine learning algorithms. So if I have here a model, this model was trained by machine learning algorithms. So in this case, how can I prepare or train models? I have to use machine learning algorithms. There are many types, a lot of types of machine learning algorithms. So, but in this case, when I decide to which algorithm I will use, I have to prepare and decide which hyperparameters I will use, or test many hyperparameters. Here in machine learning, we call hyperparameter as a parameter to configure the algorithm. So it's like a parameter, but they're not parameters used inside the algorithm, but outside to define the behavior of the algorithm. So I have here automatic model selection. Sometimes I can use it, but normally not. Model testing and model validation, because I have to test and validate that model, a model, to see if the metrics, quality metrics, are good or not so good. And we have different types of metrics as well. And at the end, we have deploy and predict. In this case, we put the model in production, and that model can be used in different systems, by different systems in some case, and we have the model prepared to be used. Steps, this step here, the process of training models. How can I train models? How can I build smart programs? So I have, first of all, I need to have data and use that data to produce models. So first of all, there is a phase, a step for training. So in this step, examples are presented to the system. It learns from the examples. The system adjusts some parameters, but this process is automatic. The output should be close to the desired result. So what's the desired result? The desired result should be, it depends on the task. For example, if I want to classify, the desired result is a correct classification. If I have a regression, I'd like to identify the future, for example, predict the future. So, and test. No examples are presented, and the algorithm, the model must work, must classify or predict or something other thing. The system should generalize and present satisfactory results. So, but what exactly is generalize? Generalization. Imagine that you show these images from many cars. You show different types of cars with different colors, with different brands, with different wheels, with different size. So I present the algorithm with, I showed to the algorithm the many types of cars. So the algorithm is able to identify different types of cars, like this. But generalization is the task of, is the capacity to the algorithm understands a new example, even if this example is word, independent of the type of the example. So this is generalization. And we have here different, as I told you, we have different types of machine learning algorithms. Machine learning can be seen as this. We have two types of machine learning algorithms, supervised and unsupervised. Supervised is when I show the examples and I say to the computer, this example has the following label. This example is a car. This example is a female. This example is a cat. This example is a dog. I show the label. So the algorithm is able to understand which type of example it is. In this class of algorithms, we have classification and regression. In classification, as I told you, we have support vector machines. These are names of algorithms. Support vector machines, discriminant analysis, naive Bayes, nearest neighbors, neural networks. Neural networks can be used as both. Regression, linear regression is the most used. Hierarchical assemblies, decision trees, neural networks. So we have here two types of tasks to supervise it. And unsupervised. Unsupervised is when I can't show the labels to the computer. And sometimes I have to give examples to the computer. I don't have the labels. If I don't have the labels, how the computer can understand? In this case, I show the examples, but the computer doesn't know the labels. In this case, it should separate, group the examples. This is the name of usage to this, unsupervised. And we have clustering tasks, k-means, hierarchical, Gaussian mixture, hidden Markov, and neural network as well. So we have here different types of algorithms. And in this presentation, I'm not going to show a specific algorithm. I'm going to give the overview of these algorithms. Probably in the practice we will see neural networks because it's the most used around the world. Yeah, but I recommend for you that you have to understand it or see and try to understand or see when you should use each algorithm, because one algorithm is better for one case, other algorithm is better for other case. In this case, you have first, after you understand your problem, you have to decide which algorithm you have to test, you have to validate, and in fact you can decide for more than one algorithm, and after that you can train those algorithms to decide which one is better. But we have many types of algorithms, and more algorithms are proposed now. Are being proposed now. So more about generalization. The generalization, we have two problems with, independent of the model. We have two problems when we train models. The first one here is underfitting. What's underfitting? In this case, we have, yes, this is underfitting in regression. Here I have a linear regression, because I have a line. Yeah, and here I have examples, many examples in orange. And as you can see, this line represents the examples. But as you can see, I have this example and this example, which is distant from the line. So in this case, this example has an error, high error. This one as well. But we have examples that has low error. Like this, or without error. And in this case, we have, when we have a line or we don't have a good accuracy in the training phase. When you don't have a good accuracy in the training phase, you have underfitting, because the training phase is not giving me good accuracy. Accuracy is the sum of false positive, true positive, and true negative. So in this case, I don't have a good accuracy. In this case, I have a model which is balanced because it's not underfit, but it's not overfitting. And I have a balanced, but in this case here, I have overfitting. Why I have overfitting? Because my line or my function, my regression, is much adapted to the examples, to the training. So in this case, when I give new unknown examples, probably this model will not get a good accuracy because it knows well the training examples, but it doesn't know the new examples, real life examples. And in this case, we have the balance. It's not the underfit and it's not the overfitting. So this is the better. This is the best. Here we have underfit in a regression, as you can see. This is regression, but here we have underfitting in a classification task. So here we have an underfitting. Underfitting is when I have a line to classify, to divide the examples. And here we have many ready objects and blue objects. But as you can see, we have red objects here and you have blue objects here. The line is not dividing correctly the sets. So in this case, we have underfitting. The training is not so good. Here we have overfitting here. As you can see, we have a function, a word function that can divide very well the sets. But if you have this function here, probably when we bring new examples, real life examples, we don't have a good accuracy in the test phase, not in the training phase. In the training phase is perfect. In the training phase is perfect here. As you can see, the line is dividing very good, but when we have new examples, probably this line is not so good. In this case, we have or in computer science is trade-off. In this case, we have I don't want to have underfitting nor overfitting. In this case, I need to have classification where I don't have much problems in the training and in the testing phase. So in this case, I have some errors here. For example, here I have a ready object and two ready objects, but as you can see, only two objects are wrong. And probably when this model receives new objects, new blue objects and red objects, it will be good. It will be good. So this is underfitting and overfitting. Yes, more concepts. Let me show this. When we read much about this area, we have artificial intelligence. The main area is artificial intelligence. But what artificial intelligence is? We can say any technique that enables computers to mimic human intelligence using logic, if-then rules, decision trees, and machine learning, including deep learning. So we have a huge area big area called artificial intelligence, which has if-then rules, logic, for example, fuzzy logic, decision trees, and other type of algorithms. And inside the artificial intelligence, we have machine learning. Machine learning is what I told you, which is a subset of AI that includes abstruse statistical techniques that enable machines to improve at tasks with experience, as I told you. And we have, inside the machine learning, we have deep learning. More specifically, we have specific algorithms which are able to, I can say this, which has specifically neural networks, but a specific type of neural networks. For example, convolutional neural networks. When I have a dense layer, it's hard to explain this now, but we can see deep learning as a subclass of machine learning, and machine learning as a subclass of artificial intelligence. And deep learning is better used when you want to, for example, classify images, or it is better with images and natural language processing. So I have this big picture here to see how we can see these concepts. And yes, what I would like to present to you about machine learning concepts is this. Do you have questions, or do you understand everything, or please tell me. I think there are many concepts, but we will put the hands on the code. I think it will be better. Questions? Let me check here. What about data science? Yes, data science. Age can be a secretary. Yes, data science. Data science. Oops. Data science is the. We can see data science as the area of used to understand the data, to apply statistical things on the data and understand the data. In fact, when we apply machine learning, when we use machine learning, in fact, we are doing data analytics, data science. We are doing this. In this practice here today, we are going to do a practice, and in this practice we are going to do data science because we need to understand the data. You know, so I think there is a measure of concepts, there is a measure of tasks, but we can see machine learning as a specific task because machine learning normally propose models. Normally it proposes models. This is the difference. Data science, no, it's not mandatory. Yes. What questions here? No. Yes, I think you know what Internet of Things is. And Internet of Things is the, first of all, you can, historically, we can see how computers are connected, were connected. Computers were made to be connected only to hosts, or after with the web, and after that with mobile devices, and after that with people using social networks. And now we have Internet of Things. And Internet of Things is when we connect everything, anything. a car, a house, freezing, or everything we can connect to the internet, and that object, that smart object, that thing will be able to send data to the internet and receive data from the internet. And what type of data? Normally, we have sensors, we have actuators sensors to sense, to understand the environment, and actuators to act over the environment, to act over the environment. So we have these objects to be smarter and to be connected with the internet and accessed from different people. So we can see Internet of Things in this view. I think you know. But how can I learn from the IoT? From where exactly? There are a lot of types of sensors, and the sensors we use these objects with us. And for example, smartwatches, smart bands, biosensors, and smart bracelet, smart belt, smart pants, smart socks, smart shoes, smart watch, and these sensors produce a lot of data. These sensors are producing data all the time, every time. And because of this, we have a lot of data. We have, from the IoT, we have a lot of data. We have different types of data, and we have a lot of data. And these data must be used to produce knowledge. And you can understand better the things, you know? So I can use different types of sensors to understand better, to get more data, and to understand better what is happening. So by using these sensors here, or different types of sensors, these are only examples. We have normally we have the following architecture. We have here what we can call edge side, where we have the sensors, we have the smart objects, we have gateways, we have actuators, more sensors and more sensors and more sensors connected to the buildings, connected to the hospitals, connected to the humans, connected to everything. And in this case, we don't have much computational power. We don't have energy, and we don't have an environment suitable to process many things. So this is called edge. Yes, here we have a smartphone as well, smartphone. And here we have fog compute, a middle layer. You can see this architecture in layers, divided in layers, into layers. And the second layers we have fog computing. Fog computing is there are gateways and other types of servers and suites, more gateways, and we don't have these are servers and gateways more closer to the end user than cloud computing. Cloud computing is when we have data centers, servers as well, and many computers, and you have here the cloud. So, but we normally learn from these, but we can learn from these, we can learn from these as well. But normally we learn from sensors, we learn from data that are produced by the users. And of course we have here billions of devices, here millions and thousands. We don't have many devices here. But why I'm showing this? Because normally we, for example, you have studied Raspberry Pi. Raspberry Pi should be put in this layer. And Raspberry Pi can be put in this layer as well, but normally in this layer. And you can think, but yes, I have to build my machine learning models inside the Raspberry Pi or not. It depends on the context, because machine learning is useful. It can be used inside the Raspberry Pi as well, but normally we don't put it in this layer. We put it in this layer or in this layer. Normally, it's not mandatory. There are many researchers that are proposing to put machine learning and deep learning in this layer. So, but it's not so common. But if I have a Raspberry Pi producing data, producing sensor data, in this case, I get that data and send that data to the fog layer or to the cloud layer to get that data and produce models and build models and create models, you know. But it's not so common to build models in this layer. After that model is created, I can put it, because it is a function, I can put it in this layer, you know. But after that model is created. Well, let's practice. I think you have a Google account. If you don't have, you need to create a Google account. But we will use a tool called Google Collaboratory or Google Colab. Google Colab is used to write and execute Python in our browser. It's like Jupyter. Zero configuration required. You don't need to configure anything. Free access to GPUs and TPUs. I'm going to show what GPUs is and TPU is. Easy sharing, because we are using via Google Drive, so it's easy to share. And let's get to know it. Maybe it would be good if you can follow me. I have here my Google account, my Google Drive. I'm in my Google Drive. Let me, yes, Colab Notebooks. I created a directory called Google Notebooks. And if you, can you follow me? Yes.
Yes, Ariel, we are following you.
Okay. Oops. Here. So here you can click on the right button of the mouse, and you use here more, and here you have Google Collaboratory. Please check if you have this option in your computer. More, Google Collaboratory. And you click. When you click, this window will be presented. And you have here a Jupyter notebook. Can you see? Yes, but I have here more notebooks prepared. I have here.
Ariel, sorry to interrupt you. I think many of the participants are following what you are trying to show. So please once again repeat the process, how you have reached here. Please once again repeat this.
Okay. if you are connected, if you are logged in the Google account, you have this option here, Google Drive. Or you can just type this URL here, collab.research.google.com. You can type this link. But if you are in the drive, you can click on the right button and more, and there is an option called Google Collaborator. And you click. When you click, this window will be presented here, which is a Jupyter notebook. Okay, yes, that's it. Everyone is here? Okay. If you want, you can talk to me. So I'm imagining that you are okay to continue.
Yes, Ariel, many of us are following.
Okay. Here I show an example, a hello world example, which is very, very simple, just to show the tool that we will use. Here we have a Python code just to print hello world, hello India, in fact. Here we have cells. These cells can be of two types, code or text. Text is this, just to comment the code. And the code is the code itself. Yes, and here we have, when we write, we don't need this. When we write a code, a line code line, we can play, and when we play, that line will be processed. Yes, here I need to, as you can see, we need to connect to, this is connected, automatically it will be connected. Just to see that we are using other machine, other computer. This computer is in Google. We don't know where, but it's in Google. And hello India, and here we have other code, name, and input what's your name, age. We have 3 variables, and I'm printing the name and age, and then the 3 variables. If I play this, I need to arrow and enter. Okay, and it will be presented. The third cell is just to show a sum, an example of sum, and I don't know, 50 and 10. Yes. Here I'm showing the sum and the type of data, or data type, and that's it. I think I'm giving 2 minutes for practicing to you. What do you think? It's the same. I think you were practicing this code like this in the last day, in the past day, but yes, just to know the tool.
We are not in Python. Previous class yesterday.
Sorry?
So the code already we are done by
Okay.
Rakesh sir.
Okay. Okay. More 1 minute. have cells here, and you can process the cells in different types. There is no order. It's like Jupyter. While you are trying to type this code, I can show some difference. One good difference is this runtime, section, factory, change runtime type. Here I can use GPU and TPU. GPU is graphical processing unit, which has parallel computing processing, and TPU is tensor processing unit. Tensor because tensor is a concept used in TensorFlow, not only in TensorFlow, but it's a concept. And this type of processor is more suitable to process machine learning algorithms, mainly neural networks. But here I'm not using, because if I use, I have to pay, or I have to I'm not sure, but I think with Google account, we have 8 hours a week to use GPU and 4 hours a week to use TPU. I'm not sure, but I think these are the times. Yes, so this is the first example. And we have here options like Jupyter Notebook. I think the main difference is the type of runtime. Yes, with processors, different types of processors, but if I use these processors, I have to prepare my code to use them. And that's it. It's like Jupyter Notebook. But the good difference is, the main difference is this about processors. But can you imagine I can share this code, and I can program this code with other participants, with other programmers. I can share it. I can write code together with other people, and this is good. This is nice. Yes, let's continue. So we have here Google Collaborator, and let's show you the main Python libraries for machine learning. We have Pandas. Pandas is a library used for data analytics, data manipulation, and analysis. We will use this library because we have to use it, because when we need to manipulate data, we need to know the data, we have to use Pandas. Pandas is the fundamental. So it offers data structures and operations for manipulating numerical tables and time series. And it's like Calc, it's like Excel from Microsoft, but using code, using programming language. And we have NumPy support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. In fact, you need to use NumPy as well when we are using TensorFlow, but TensorFlow proposes specific types of data called tensors. I'm going to show you them. So NumPy, Matplotlib, and Seaborn are plotting libraries. We need to have any one of these libraries, because we need to see the data, not only we need to see graphics from the data to understand better the data. So we use Matplotlib and Seaborn. Scikit-learn. Scikit-learn is the most used machine learning library. It really much used. It provides a lot of algorithm implementations. Reduce, maybe we will use it, I'm not sure. But yes, scikit-learn is much used. PyTorch is the concurrent of the TensorFlow. It's used for deep learning. And it competes with TensorFlow. Both of them have advantages. And we have Keras. Keras is built on top of TensorFlow 2.0 or 2.2 now. And Keras is a API for machine learning and deep learning. And TensorFlow. What about TensorFlow? It's Google's machine learning, deep learning library. In fact, it has more than one implementation of machine learning, deep learning algorithms. It's a symbolic math library for data flow and differentiable programming. Different concepts are used. We need to understand TensorFlow. We need to know two main concepts: graph programming, and tensors. So to understand what this sentence means, we have to know graph programming or graphs. I'm going to show it. And tensors, what tensors are. And we are now in the TensorFlow 2.2. And TensorFlow has many tools, extensions, and ready-to-use models. I'd like to show this TensorFlow Lite used for IoT. And this playground is nice to understand neural networks. I'm going to show you this tool. Here we have a dashboard for a neural network, and here I don't know if you understand what a neural network is, but let me introduce it. A neural network is a type of algorithm which it has different layers. Here we have only 3 layers: an input layer, hidden layer, and output layer. And these layers have many neurons. Here we have 4 neurons, 2 neurons, and 2 characteristics used as input. And here we can see this algorithm working. For example, can you imagine this type of data? Let me check here. I'd like to classify blue and yellow points. So I have 2 characteristics to classify them, for example. And I have here a hidden layer. Let me put more neurons here, 8 neurons. I don't know if you are following, or you can try it. Yes, you can use code share, of course. You can share the code. At the end, I can differentiate the machine learning and data science. Coming back here. So nice, I can learning rate, activation. I have different types of activation functions, regularization functions, and so here I have a type of problem, classification. So I'd like to classify blue and yellow. It's easy. No? This is because we don't have mixed points in this case. So we can play, and here it's easy to. In this case, we have the laws of zero. You can pause, and I have a function to divide the data. So, but let me see this type of data, which is hard to classify because they are put together. It's hard, it's really hard. So let me put more hidden layers. So only 2 neurons here. And let me put more characteristic features. Classification. Yes, play. In this case, as you can see, my neural network is trying to divide the data. As you can see, it is working to divide, but it's not easy. You can see they are reducing the error to produce a function which is useful to separate the data between blue, to classify the data between blue and yellow. But it's not easy. Maybe it's okay. Maybe it is classifying. Yes. Pause. As you can see, we have here a function which is divided. But here, I think it's not okay. It's wrong here because we have blue, and here we have yellow points. Yes, it's okay here and here. Only yes. On here you get wrong. Yes. And here we have a dashboard to understand, to try to see how neural networks works, and how it is prepared, how it should be seen. Yes, I have other tool here. This is cool. It's an extension of TensorFlow. It's a framework, in fact. Let me show it. It is OSNet. As you can see me, this is me. Yes. In real time, it is identifying 70 points. My different points here, my eyes, my ears, my I'm not sure if the mouth, no, not mouth, but my, yes, my, as you can see here, oops, yes, here, and should be, yes. In real time, it is trying to identify these points and drawing segments, lines to between points. Yes. In real time. It's good. I think you can try it. Let me close and put the link. Yes. Yes. You can try it. 2 minutes to try it. It's nice. It's cool. PostNet is a framework, is an extension of TensorFlow, which is used for, it's a image processing algorithm. It's a, it uses TensorFlow to identify those points. And here in Brazil, I have a student which is trying to develop an application, mobile application to identify scoliosis and lordosis and different types of human posture deviations. It's nice. So, let's continue. And we have many tools, extensions, and where to use. Maybe I should present TensorFlow here is the website. Yes, TensorFlow. This is the website of the TensorFlow. And we have here the documentation, learning TensorFlow, for example. Here we have the documentation, guide, tutorials, and from community we have forums and etc. We have resource. Here we have, for example, tools. TensorFlow Playground, as I told you. Collab, we are using Collab. TensorBoard is good, it's nice to see what's happening with our model, and many others, tools and libraries, extensions, etc. Yes, we have to understand, as I told you, we have to understand two concepts to work with TensorFlow. And let me check here. Okay. And the first one is tensors. What tensors are? Tensors are multidimensional arrays. We can have an array with only one value. We can have, or in this case, it's not in an array. In fact, it's only a constant. We can have an array, in fact, only one dimension, with, in this case, with 3 values. We can have an array with 2 dimensions. In this case, we have 3 lines and 2 columns. And you can have multidimensional or 3x dimensional arrays. In this case, we have 2 lines, 5 columns, and 3 matrices, in fact. 3 matrices with the same size with the same size. So we have tensors. Tensors are these. But let's practice to understand better about this. I'm going to show the second example here. Here, this is the beginning of my second code. This is a text, and I put text here, text, and I can share the notebooks for you after the presentation. I can share these and this one. Yes, this is big. And this is the second one. I can share after the presentation, the notebooks. And here I'm importing the TensorFlow as TF. I'm print the TensorFlow version. So let me play this, run. 2.2, as I told you. Here I'm creating different types of sensors. I'm creating a constant with only one value. I'm creating a vector with 3 values. I'm creating a matrix with 6 values. And I'm creating 3-axis dimensions matrices. It's, in fact, 3 matrices. 3 matrices, in fact. In this case, N, N, and N. And I'm creating. So, okay. Just to see what matrix with double X is. Here, as you can see, matrix is the data type is, in fact, it's an array, NumPy array. It's a tensor, as you can see, it's a tensor with the following shape: 2 versus 2 versus 3, and we have an array with but dimensional array, and the data type is int. Let me print matrix, this one here. Yes, TensorFlow, it's a tensor, as you can see. I have a matrix here, just a matrix, and we have a shape, and we have a data type. These are tensors, but what's the difference between tensors and other type of data? Tensors are prepared to be used by TensorFlow, and TensorFlow can understand better the tensors, because tensor is a data type with the data itself and the shape and the data type, and it can manipulate and apply functions and apply it can apply different types of functions over these tensors. Here we are creating, just to I think you understand better when I show you what the second concept is, which is graphs. So let me first introduce the code. Here we are creating the many tensors. Tensor A, which has the value 3, tensor B, which has the value 5, tensor C, which has the value 10, and tensor D, which has the value 7. Just constants. And we have here, I'm applying a math calculations, and I'm multiplying A and B, and save the result in the variable E. And here I'm adding C and D, and saving the result in F. And here I subtract the result from F from the result from E, and save it in G. As you can see, we have a dependence here. We have a dependence. To see the value which is here in G, I first need to subtract F and E, but when I get the F needs to add C and D, and when I here I need the E needs to multiply A and B. So I need to first create these constants to calculate everything, calculate all the code. So I have a dependence. This dependence is called graph, because I have G, and G depends on the many others variables. So in this case, I print G. In fact, if I execute this code, nothing happens. In this code, there is nothing to happen. And when I need to print G, here I'm really executing this code, because only here I process something which has dependence from these other lines. In this case, I have a tensor, because G is a tensor, and it has the value 2. If I calculate this, I have this value. The shape is n, like this, like a constant. It's not a vector, it's not a matrix, it's not a matrices. And the data type is int. Let's see here. So here we have that example of graph, and we have constants 3, 5, 10, and 7, and we use it then to multiply here, and we have the value of E, and here we have the value of F, because I added 10 plus 7, and here I subtract the value used, the result of G is a subtraction, and it can be used for different purposes. So, but we can think, what's the advantage to use this type of programming? Because as you can see, I execute this code. This code depends on this code. This code depends on this code, and in this case, I have a graph. And why do I need this graph? What's the advantage to use this type of programming? The advantage is because these codes can be processed by different processors. Here I can put this code in a processor, and I can put this code in another processor, and these codes can be processed by different CPUs, GPUs, TPUs, and I can run this code much more quick, much more fast. So this is the advantage to use the graph programming, which is in the TensorFlow. Do you have any questions about this, about tensors and graphs? Do you have any questions? Can I continue?
I request the participants, please ask questions. I think we are going through a wonderful session, and some of you are posting the questions as well, but you may please feel free to ask Arial whatever you wish to. Participants, any question?
Okay, let's continue. Yes. So this is the concepts that I'd like to present to you. And at the end, we have to practice. We have to produce a model. We have to build a model, a machine learning model. So I brought an example used in IoT example, in fact. And this example is cool to exemplify the use of machine learning in the IoT paradigm. And first of all, we have to understand the problem. as you have to imagine the situation. We have a data set with measures of an atmospheric pressure sensor. So we have a temporal series from 2010 to 2014. Many measures made by a sensor, atmospheric pressure sensor, like this. So you have these measures, and we would like to predict future values from previous values. Can you see? We would like to identify what the values will be presented, will be got from the sensor. But I ask you, what is this problem? Can you help me? This problem is a classification problem or a regression problem? What's your opinion?
Regression problem.
Exactly. It's a regression problem because I need to predict the future values. In this case, what are the next values? So this is what I'd like to know. So here I have a Jupyter notebook prepared, and let me show it. Here I'm importing pandas, NumPy, Matplotlib, Seaborn. In fact, I'm using only Seaborn. Yes, but I'm not sure. Yes, I think I'm using both. And data time. Yes, I'm importing these libraries. And here I'm importing dataset. The dataset you can get from this. Let me check here. I'm sharing. I have to share these for you. Yes. Share. Copy link. Yes, you can download this dataset, please. Yes. I run this. Matching, analyzing. Yes, it's okay. And I have to import the data set. Would like to type the code to follow me?
Yes, sir. Yes, sir.
Okay. First of all, download the data set. Should files, data, 2 megabytes.
Sir, can you share the Python code file?
The code? Do you have the code? Yeah?
Yes, sir.
Let me check what is the, I think it is share. You can get the code, the notebook. But you have to download the notebook and upload it in your drive. Yes, here I have imported the data set, and now I have to get the data set. Here I have the data set, data CSV, which is the format of the file, and I create a data frame, which is the format used by pandas, data frame, and I get the data set to and put it in my data frame, which I call it data frame df underscore pollution. So let me execute here. Yes, and now this function is pandas function, which I see the data set. I have here a table, a data set. Let me show more lines. For example, 50. I have here 50 lines of my data set, and I have many columns: month, day, year, number. I don't need number, in fact, but year, month, day, hour. I don't know this. New values, but I don't know what PM is. And this, I don't know as well. Temperature, I think. Pressure, yes. Atmospheric pressure, what I want to understand, yes. And other types of values that I don't know. Let me put only 5 lines. Yes. Here I check the shape. The shape is the size of the data set. Here I have 53,824 lines and 13 columns. And here I get information about my data set. And here, as you can see, we have the linings, we have the columns and the data type of the columns, and we can check if you have new values. As you can see here, we have less lines than the maximum entries. But you can see here better. I'm counting the new values. We have 2,067 new values in this column. And as you can see here, we have a month. We have 1, 2, 3, 4 columns to represent data. It's not so good to predict something. I have to put this data together using data type, data time, in fact. So here, this line just put those columns, these together. So I run this, and now I have then a new column called data time. As you can see here, I have this new column because in a regression, I just need to have, I don't need to have, in fact, I use only data time and pressure because the other values I don't want them. And just to know my data set, it's important to know our data set. And here I get the maximum and minimum data times. So as you can see, we have the data time from 2010 to the end of the 2014 year. As you can see, max data time and mean data time. This is important because, as you can see, we have 4 years of data set. And here I create a new data frame with only 2 columns, data time and pressure. Because we are interested in these values, only in this type of values. I don't want temperature and the other ones. So in this case, I have to create a new data frame, which I call it DF pressure from DF pollution, and I got only data time, which is 1, and pressure, which is this, and I create a new data frame. So let me, and I use the red hat function to show the data. And here I have only this data frame. I have two variables. Do you remember in regression? In regression, you have two variables. In fact, in linear regression, but I can have more than two variables, but in this case, I have only two. And here I'm sorting the values because maybe it can be disordered, and I need to sort by data time to create a temporal series. In this case, yes, I ordered, I sorted the data frame, and now I'm checking outliers. I need to check if I have outliers in my data set, my data frame, because sometimes if in regression problem, I need to eliminate outliers. Outliers are values which is word, which I don't like to have. They are different values, and I have to delete these values. But in this case here, I don't have outliers, because if I had outliers, there would be points here, but I don't have points here to show outliers. I'm plotting the box plot graphic. In this case, I'm using Seaborn. Seaborn is this library here, Seaborn. So I don't have outliers. Great, because if I had outliers, I'd have to delete this data. Now I'm plotting the values. I need to understand the values. So in this case, I'm plotting the values. As you can see, we have a temporal series. The values trends over the year. Yes, I think over the year. 1 year, 2 years, 3 years, 4 years, I think. And the values are height and low, height, low, height, low, height, low, height, low, yes. Temporal series. And yes, now I understood my data set. If I want to know more about it, I have to print, I have to use head or head function or info function. Info function, yes. These functions are from pandas. Yes. And now I have to prepare my data set. I have to pre-process my data set. In this case, I have to normalize my data set. But you can ask me, why should I normalize my data set? Because machine learning works better with normalized values. So in this case, I have to normalize them, and I normalize it from 0 to 1. So these values, which are from 1040, maybe, from 990, more or less, to 1000 or more than 1100, maybe, probably here. And I normalized them to put the data from 0 to 1. So I use this library, which is scikit-learn. You can remember this library, scikit-learn. So I put the data, normalize it, and this line only put the data, normalize it, and I get the data from this column and create a new column called normalized pressure and show this data. Let me show it. So yes, I have now normalized pressure which is the values normalized from 0 to 1. And now I have to split the data because I have the training values and I have the testing values. But why do I need this? Because I have to give the training values to the computer, understand the examples to learn, and I have to use the testing values to show new examples. I use the test values as like no examples. And I give, after training the model, I give the testing values to the computer just to check the accuracy, the quality metrics, normally accuracy and precision and recall and F-score and the other types of quality metrics. But when I get testing values, I'm getting the value that I will use to show to the computer, to the model, new values, like no values, real life values. So I had to split the data set. In this case, which is a temporal series, I in fact here, I divided the data set in 75% 3 years to the training and 1 year 25% to the testing. So let me execute this. Yes. As you can see, we have now 2 data frames, data frame training, data frame test. And now we have data frame with many lines, with these many lines. And now we have to analyze, in fact you don't need to analyze, but it's good to see the training values, the training data set, the training data frame, which is this. I'm showing only the training data frame, which is this, yes, like this one before, yes. But here we have 4 years, here we have 3 years. And the testing, here I'm seeing we're looking at 1 year, just 1 year, because this is the testing data set, just 1 year. And here, in here, in fact, I'm preparing the data to put it in the NumPy format. Why NumPy format? Because NumPy format is used by TensorFlow. So I'm just putting the data into X training, and training and testing, just to preparing the data to touch to the TensorFlow. In this case, I have a parameter just to understand this parameter, which is important. This parameter shows that I'm using 10 previous values to predict a future value. So I'm using 10 previous values to predict the next one. In this case, I'm using 10. This is a hyperparameter for my regression. So in this case, I don't know if this value is good or bad, but I'm trying. If my model is gonna be okay, it's gonna be good, it's okay. But if it's bad, I have to change. I can change this value to try a better result. So here, yes, exactly, and this, that's it. So now I'm starting to use the TensorFlow, in fact. Here, I'm going to do a prediction via neural network using keras. In fact, keras is, in fact, I'm using deep neural network. Deep neural network. It's not a convolutional, but it has different dense layers here. Dense layers. And I import TensorFlow and other libraries because I need to use them. So first of all, I have to build my architecture, my neural network architecture, like this one, Yes, like this one. I prepare my architecture. So here I have to prepare. I'm preparing the input layer with 10 features like this, 10 features. And I use three hidden layers. The first one has 32 neurons, the second one has 60 neurons, and the third one has 60 neurons as well. And I added one more dropout layer, which is used to avoid overfitting. Try to avoid, sometimes doesn't avoid. And dropout is when in each interaction, I trained my model, I trained that layer, remove it, in this case, 20% of I trained the layer, 20% of the neurons. And I have here output layer, which has only one output, which is this only one. It's the next value of the atmospheric pressure. So here I predict this value. So I need to know only one. But if I need to know two more, I have to put, I can put two more, two here, the number two. I'm using these architectures, which is called multi-layer perceptron. You can check here. And here I'm effecting building the model. In this case, I'm really compiling the model. Not exactly compiling, but I'm building, I'm preparing here and I'm building here. Here and here, let me check if I run. I have first of all execute here, and now here, it's okay. And now I have to see the summary, just to see my architecture. And here I'm in the input layer, dense layer, dropout, dense layer, and output layer, which is it's not showed. And as you can see here, I created the input layer. Let me check. I created the dense layer 1, and I put the input layer as input layer. And I created dense layer 2, and put as input the dense layer 1. I created the dense layer 3, and put the dense layer 2 as input. And after that, I created the dropout layer and put the dense layer 3 as input. In this case, I'm just creating this one. I'm creating the sequence of layers. As you can see here, let me show. Input layer, dense layer, which are the hidden layers. Here, dense layer. When I call dense, it's because they are connected with all of them. This neuron is connected with both. This neuron is connected with these ones. So in this case, we have a dense layer. All of them are connected to all of them, from the previous layer to the next layer, only the next one. And the output layer at the end, dropout layer. There is no dropout layer here. There is dropout. There isn't in this case. Yes, but here I have output layer. Sorry. And that's it. Here I can see my assumer of my model. So that's it. I have many connections. As you can see, I have more than 500 connections in this layer here. Many connections. Connections are these. Connections are these. These are connections between neurons. So here I have to compile, and now I'm going to train. Here I'm specifying epochs, just 20, because if I put more, it needs more time. Let me put just 20. But if you want to have more good results, you can put more. Yes, now I'm not using GPU or TPU. If I'm using GPU or TPU, the time is much better. Just 20. Yes, I'm finishing. As you can see, the loss is decreasing. The loss is decreasing, yes, but yes, 20. Okay, it's finished. And now I'm checking if our model is predicting correctly. In this case, I have to prepare this first. And now I have to check this coefficient. This coefficient of determination is called R squared. It's not easy to explain this because we don't have much time, but this number here represents that our model is very good, very good, because it, 1 is the best. So we are in almost the number 1. Now, the ending, we can plot and see how our model is working. In this case, we have 2 lines, and you can imagine here this actual line, green line, is the real value. And our model are predicting almost the actual value. Green in the line predict. Yes, here almost there. So as you can see, we have errors. Yes, it's normal, because if you don't have errors, probably we have an overfitting. But as you can see, we have a good model to predict atmospheric pressure data from sensors. As you can see here, we have, let me get here, yes, normalized readings, this is the index, and the atmospheric pressure, this is the data. We have only, I'm showing just the 51 values. Let me try to show more. Maybe, probably, let me show here because I have to change it here, page. But I don't need to, yeah. Yes, here I have more values. As you can see, we have almost, yes, my model is good. My model is like excellent, in fact. Excellent. My model is excellent. But it's easy. This data set is, as you can see, this data set has which we call, we have seasons here. We have seasons. It's easy to identify. It's easy to predict. So we have a good model here, even with 20 epochs. Even with 20 epochs. If I put more epochs here to train my model, of course I will have a better result. But my result here is good. Okay? Yes, I think I have finished. I don't know if you have questions, but if you have questions, you can do it. So then, so tell me.
Participants, please feel free to ask questions. Please clarify your doubts.
What's trainable parameters and non-trainable parameters? Which line? Let me check which line. Professor Srinivas. What's the trainable parameters? And
Yes, sir. When I'm running this summary, model summary, it was showing that total parameters 1169, trainable parameters 1169. So what are they actually?
do you remember which line?
It's a 25 summary of the model. MLP
Okay,
underscore model.
yes, let me check. Summary of the model. Yes. Yes, the total parameters are the sum is the sum of the connections between neurons.
Oh, okay.
Or the question with okay. Joseph, which better, GPU or TPU? For TensorFlow, TPU, of course. But for other types of processing, maybe GPU. But TPU is made to be used for TensorFlow, to be used for processing tensors.
Sir, what is the purpose of using dropout?
Dropout? Dropout is
Yes.
used to dropout is used to, in each iteration, in each epoch, I remove, in this case, 20% because I put 0.2. I remove that 20% of the neurons to avoid overfitting. Even if I get a good result, I drop out. I put off 20% of the neurons in that layer, only that layer. This is used to avoid overfitting, because sometimes my model can understand much my training data, but it cannot understand my testing data. Yes, I think we have finished it, but if you have more questions, my email is, let me share my email here. Yes,
Sir,
my email is on the presentation. Sorry?
Can you please share the PPTs also?
Yes.
Ariel, you may send whatever material you can share. You can share it with me, and I'll share with all the participants, along with some of the code snippets that you said which are possible. So please share with me, and I'll share with all the participants.
Okay. If you have questions, maybe I can help in something. But this area in research area, and not only research area, but industry area, machine learning is a hot topic, as you can see. So it's good. Maybe
yes, your
can...
email ID is with the participants, and I believe if not today, maybe over a period of time, certainly some of them, like I can see some of the participants, Professor Srinivas, George, and many other participants are actively following your session. So they may have some queries over a period of time, and definitely they'll come over you. So I request you to please assist the people who are working in this field.
Yeah.
And any more questions from the participants? So I think, Ariel, it is we had a superb session. Thank you. And I know you had to wake up early today. So it is, I think, around 9:30 a.m. over there. And just over 6 p.m. in the evening over here in India. So on behalf of all of us, all the participants, speakers, myself, I am highly thankful to you for a beautiful session. Certainly we learned a lot, and more than that, I am sure people will come over you over a period of time.
Thank you for the opportunity, Nishu, and it was great to be here.
Yeah. Okay. Thank you very much. Now I am closing this session. Have a nice day. Bye-bye to all of you.
Have a nice day. Bye-bye.
Namaste, Ariel. Namaste.
Thank you, sir.
Thank
okay,
you,
all the participants. Okay, madam. Bye. I'll collect the material from Ariel, right? And I'll share. Video you will be getting tomorrow, and material as soon as he shares, I'll share with you all. Professor Rakesh sir will be processing the video, and then we'll share with you. But study material, I believe we can share today itself. Thank you all of you for the session. And for tomorrow's session, we'll post everything on the group as well as on your email. So stay tuned for one more day. Thank you very much. Bye-bye.